Welcome to this guided example on how to compare the performances of gas boilers, heat pumps and chillers. We have already studied the environmental performances in terms of primary energy, resource depletion and CO2 equivalent emissions. We are now going to add investment and operational energy costs. Costs may be very country dependent and varies also in time, so please be aware that the costs in this example are again just used as an illustration and cannot be claimed to reflect current or local reality. Our case will be the same building as in the MOOC energy demand in buildings. We simulated its complete energy use during a typical year representative of the Dutch climate. In the present guided example, we are interested by the space heating and the space cooling. The data we need to calculate the performance of energy supply systems are the annual space heating demand, 854 megawatt hour, the nominal power for space heating, which is 421 kilowatt, and of course the cooling demand, which is approximately 298 megawatt hour, and a cooling power of 921 kilowatt. We want to compare the two following options. First, the use of a condensing gas boiler for heating with an efficiency of 0.95 and an air-air heat pump with SEER2 for cooling. Second, the use of a reversible ground source heat pump with SCOP5 and SEER4. The price of boilers in the Netherlands is around €70 per kilowatt for a gas boiler, and the price of a reversible heat pump is around €1,500 per kilowatt heat, and the price of a chiller is €1,000 per kilowatt. Next to that, we pay 22 cents per kilowatt hour to the energy company for our electricity, and gas costs 65 cents per cubic meter. Let's start with the gas boiler and the chiller and study first the gas boiler. The final annual energy is therefore 854 divided by 0.95, which is 899 megawatt hour in the form of gas. Gas is a primary resource, therefore eta PE to final is 1. And the annual primary energy is 899 divided by 1 equals 891 megawatt hour. Let's now consider the energy content of gas. According to an earlier lecture, it should be 9.8 kilowatt-hour per cubic meter. The resource depletion is therefore 91,735 cubic meter. Let's look now at the CO2 emissions. We saw in a former lecture that the Dutch government considers the emissions to be 0.2 kg CO2 equivalent per kilowatt-hour primary energy, which leads us to 180 ton CO2. What about the annual electricity bill? Well, with a price of, annual gas bill. With a price of 65 cents per cubic meter multiplied by the number of cubic meter, we come to annual costs of €59,628. And what about the investment costs? We saw that the nominal load is 421 kilowatt. The investment costs of a gas boiler were set to be €70 per kilowatt, which brings us to a total of €29,470. Finally, the service life of the boiler is 15 years, so the annual equivalent investment costs are 29,470 divided by 15, which of course is €1,965, by which the total energy costs amount €61,593. Let's continue with the chiller. The total annual cooling demand is 298 megawatt hour. The SEER is 2. The final annual energy is of course electricity, and the amount of needed electricity is 298 divided by 2, which is 149 megawatt hour. We now need to calculate the primary energy. For this, we need the efficiency of making electricity. In the Netherlands, this efficiency is around 0.4. The annual primary energy is therefore 372 megawatt hour. If we know the electricity mix, we can find it in a previous lecture. You can estimate the resource depletion for each of the fuels belonging to the mix. 59% comes from gas with a heating value of 9.8 kilowatt-hour per cubic meter, and 14% comes from coal with a heating value of 196 megajoule per kilogram. We neglect the 1% oil here, and the remaining part is sustainably produced, and we assume the same efficiency of 0.4 for all power plants. This leads to the depletion of more than 22,000 cubic meter gas and 0.6 ton coal. Let's now look at the CO2 emissions through the emission factor of electricity, which is 0.46 kg CO2 per kilowatt-hour electricity in the Netherlands. The annual CO2 emissions are therefore 149 times 0.46, which is 68 ton CO2 equivalent. What about the annual electricity bill? Well, with a price of 22 cents per kilowatt-hour, we come to an annual bill of 149 times 0.22, which is 32,780 euros. And what about the investment costs? We saw that the nominal load for space cooling is 921 kilowatt. The investment costs of chillers were believed to be 1,000 euro per kilowatt, which brings us to the total investment cost of 921,000 euro. Finally, the service life of a chiller is 15 years, so the annual equivalent investment costs are 921,000 divided by 15, which is 61,400 euro, by which the total energy costs amount 94,180 euro. And of course, we'll have to sum up all this with the annual costs and emissions of the boiler. We will do that a bit later. Let's continue with the reversible heat pump. It will produce both heating and cooling. The final annual electricity demand is then 298 divided by 4 plus 854 divided by 5, which is 245 megawatt-hour. In the Netherlands, the efficiency of making electricity is 0.4. The annual primary energy is therefore 612 megawatt-hour. With the electricity mix, this leads to the depletion of almost 37,000 cubic meter gas and 1 ton coal. Let's now look at the CO2 emissions with an emission factor of 0.46 kg CO2 per kilowatt-hour electricity. The annual CO2 emissions are therefore 245 times 0.46, which is 113 ton CO2 equivalent. What about the annual electricity bill? Well, with a price of 20 cents per kilowatt-hour, we come to an annual bill of 245 times 0.22 equals 53,900 euros. And what about the investment costs? We are now using only one device for heating and cooling. If we size it for cooling, which has the highest power, we will need a compressor power of 921 divided by the SEER, which is 230 kilowatt. This power times the SCOP, which is 5, leads to a heat delivery of 1150 kilowatt, which is more than enough as we need only 421 kilowatt. The investment costs of reversible heat pumps were 1,500 euro per kilowatt heat, which brings us to a total investment cost of 1,150 times 1 million, which is 1,725,000 euro. Finally, the service life is 15 years, so the annual equivalent investment cost comes to 115,000 euro, by which the total energy costs amount 168,900 euro. This table shows the summary of the performances. For the gas boiler with chiller, we have to add the performances of both, of course. In the end, we see that using the reversible heat pump leads to CO2 saving by 85%, while the costs have increased only by 8%. Not such a high price for sustainability. What could also be done with the reversible heat pump is to size it for heating, which would cover only 337 kilowatt of the cooling power, and the remaining part of the cooling could be done by evaporative cooling, which have very low costs, uses almost no energy, and has zero emissions. This way, the annual energy costs will drop a lot and be even lower than the ones of the conventional boiler with chiller. Thank you for your attention. I hope you have enjoyed this exercise.